Hello everyone. We're going to continue slope, and today we're going to be doing the formula. Okay, yesterday we did rise over run, just right here. How much the line rose over how much it ran. Okay. Well, today we're going to work with the formula, because sometimes you're just given 2 points and you don't have a graph. Okay. So just a couple things to remember whenever you're plotting points. You have an x and a y. Okay. And then we're having 2 points, so we have an x and a y again. All right. The formula again, remember m stands for slope. Okay, the formula is your y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And don't let those 1s and 2s bother you or anything. These just say what point we're talking about. So let's say this is point 2 and this is point 1. Okay, so this would be x sub 2, y sub 2, x sub 1, and y sub 1. Okay, you can't change them up. All right, don't do one as x2 and then say that's y1. Okay, they either both have to be 2s or both have to be 1s. Okay, and it's a subtraction problem with division. Remember, slope is change in y, so we're going to subtract our 2 y's. Whenever we talk about the change in something, we're subtracting over the change in x, and then we're going to subtract our 2 x's. Okay, so let's try a problem. Okay, so here's the first one. The first thing I would do with these is label them. This is going to be x sub 2, y sub 2, x sub 1, y sub 1. Remember, x always comes before y on this. Okay, so my slope is m equals, okay, remember it's y sub 1, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so now I'm just going to plug in the numbers. I'm going to go ahead and put parentheses. Fewer mistakes that way. So instead of y sub 2, I'm going to find the 4 here is y sub 2. So I'm going to put a 4 there. Okay. And then next one is y sub 1, which is 1. So I'm going to go ahead and put a 1 there. And then down here, I have x sub 2, which is the 3. Okay, so I'm going to put a 3. And then x sub 1, which is right here, is negative 7, so I'm going to put a negative 7. Okay? And then you're just going to go ahead and figure out, remember, rise and run is, our slope is rise over run, it's a fraction, so don't worry about dividing. Okay? So we have 4 minus 1, which is 3, and then we have 3 minus a negative 7. Remember to change, okay, so it ends up being 3 plus 7, which is 10. So my slope is 3 over 10. So for every time it rises 3, it runs 10. This is a positive slope, so I know my line is going uphill. Okay. All right, let's do another one. All right, so again, I'm going to label. This is x sub 2, y sub 2, x sub 1, y sub 1. Okay, you can actually switch them if you want. I always do the second point first, just so it's easier to subtract. But you can subtract in any order, it doesn't matter. So again, slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, I'm going to go ahead and put my parentheses. I labeled them. So instead of y sub 2, I'm going to put a 4. Okay, it's just a big substitution problem. All right, and now instead of y sub 1, I am going to put negative 2. Oops, let me change the colors. Now instead of x sub 2, I'm going to put negative 6. Okay, and then instead of x sub 1, I'm going to put a 3. Okay, now then you have 4 minus a negative 2, which is 4 plus 2 is 6. And then negative 6 minus 3 is negative 9. Okay. Now this one can be simplified. We should always simplify our fractions. So 3 will go into both of those, and that's negative 2 over 3. Okay. So my slope is negative 2 over 3, which means my line is going downhill. Okay. All right. Now you notice I changed the negative to the numerator, and it doesn't matter where the negative is. I just, as a personal preference, always put it with the numerator. You can put it out in front, or you can put it with the bottom. All right, this is a table. So this we're dealing with slope, which is also rate of change. Okay, and what I want to know is if there's a constant rate of change between each minute here, between minute 1 and 2, 2 and 3, and 3 and 4. And if it is, what is the rate of change? So we have to check and make sure the change is the same. Okay? So we need to do the formula quite a few times. Okay? So I'm going to go ahead, this is your x value, and this is your y value, just like a T-chart, okay, that you did in the 8th grade, x and then y. Okay, so I'm going to go ahead and try to find the rate of change between 1 and 2. Okay, so if you want to label them, this is x, so we can go x2, x1, y2, y1. Okay, so slope equals y sub 2, which is 260, minus y sub 1, which is 520, okay, over x sub 2, which is 2, minus 1. I'm sorry, 1 minus 2. Sorry about that. Okay, and this is negative 1, and that is negative 260. Okay, now two negatives, remember, make a positive. So this is 260 feet every minute. Okay, so that's the rate of change between 1 and 2 minutes. Now what I need to see is if it's the same between all of them. So now my x's and y's are going to change. Now this is going to be x sub 2, x sub 1, y sub 2, and y sub 1. Okay. So now my slope is going to be 520 minus 780, and then 2 minus 3. So we get negative 1 and negative 260, which again is a positive 260 feet per minute. 1 minute. Okay. So far so good. See how the rate of the changes are the same? Okay, and that's what I want. Now we need to check it one more time. We need to check between 3 and 4. Okay, so let's... Oh, it's not going to let me. Oops. Okay. Alright, it's not going to let me erase those. So let's just say this is x sub 2, this is x sub 1, and this is y sub 2, and this is y sub 1. Okay, so same thing. So slope equals 780 minus 1040 over 4 minus, or over 3 minus 4. Remember, you got to do the same order. Okay, so that's negative 1, and that's negative 260 again. Two negatives make a positive, so I get 260 feet for 1 minute. Okay, is my rate of change. And you notice the rate of change are the same. Okay, so it has what we call a constant rate of change because they're the same, and the rate of change is 260 feet per minute. Okay, all right, that's it. Guys, make sure you take good notes, and we'll see you in class.